a bit of a catchy title, right? Like the agent execution gap. We have all heard the stories and the reports from various, consulting firms and including MIT and all, right, as to why a lot of agentic projects have been failing and people are struggling to put things into production. So what I wanted to do in the next few minutes was talk about why that might be the case, some of the learnings, and how at Orkes we think about building agents that actually can go to production and work at scale. So I'll start with this statement right here, is that it's not that the agents are not working. I think when you are building a POC, when you are testing it locally, they are working, right? Like we all have seen that, like, when I tried out using a framework or an SDK with OpenAI or ADK from Google or whatever it might be the case, they work. What goes wrong is that they can't run in a production environment, right? The moment you try to put it in production and then you start thinking about various aspects of how do I run this agent at scale, and that's where things starts to kind of fall apart or start to kind of show its fragileness. And this is where all this what if comes, right? What happens if my agent is going to take hours to complete, because not everything is going to be get me the weather for New York City. It could be also, hey, churn through the megabytes and megabytes of data and run it in a loop, come up with an answer, make bunch of tool calls and everything, and the whole thing could take hours to do. So how are you going to run something for that long of a time? And what happens in between if things crash? Like, if you want to restart everything from scratch, from all over again, what really happens there? And, if you are putting humans in the loop, what happens if somebody does not respond? Like, when I'm running Claude on my laptop, it often asks me if I can execute a particular command or not, and I can say yes, no. But that's not typically how you are going to run an agent in production environment. So, like, how those humans are interacting with the agents. What happens if somebody is on a vacation who is supposed to approve a certain action? What really happens then? And more importantly, agents are essentially what? They use the context, they use the knowledge, they use the LLMs for reasoning and planning, but they also need tools. They need tools to be able to execute actions. They need to have access to the tools so they can query stuff and so forth, right? How am I going to make all the tools that I have built over the years, like APIs, microservices, workers, everything, right, available to an agent? Am I going to kind of rewrite everything as an MCP? What about the investment that I have to do to kind of get that thing done? And finally, let's say I get through all of those things. I have an agent running in the production, and now the next question comes is, I need to get insights into its agentic decision-making process, because the agents are running, might be going beyond just a regular, query operations, right? They might be doing things which has real implications on the business. Like, for example, let's say it's trying to onboard a customer and it is rejecting the customer to be onboarded. Why did that happen? Like, how do I get insights into why it is taking certain actions, what went into making that decision, and so forth. So this is where, the complexities come, right? And this is why, when you think about going beyond the co-pilots and chatbots into, building a POC into production, the lack of a clear path to put those things to production becomes much more clear, that, it lacks something more fundamental. And primarily, what I want to point out here is, the reason why that happens is because while there are a lot of frameworks and SDKs to build agents, there lacks a cohesive runtime for agents, right? So you need essentially a runtime environment where agents are living and breathing. If we all have come from those worlds where, like, if you think about putting a system in production, you need some sort of application server, right? Like if you're writing stuff in Java, you're using Spring Boot, you're using some app server, Tomcat, Jetty, whatever might be the case. But you need a runtime, right? You need a middleware, something that agents are running, which are able to kind of then publish its state. It's managing the runtime of the agents. And yeah, so essentially agent needs tools to be able to execute stuff. Sorry, I think something is happening here. They need the. It doesn't like that slide. All right, I'm going to try as fast as I can before it moves on. But yeah, essentially they need tools, context, and more importantly, they need orchestration, right? They need a durable distributed runtime environment for them to be able to execute. I think there might be something here. No, there's no mouse here.
Try it. Just click back. Yep.
All right. Sorry about that. All right. So what does that runtime for agent looks like, right? Like it needs to be able to call tools. They often need to coordinate with other agents, other tools, humans. They have to respect SLAs. If things fail, if things time out, they need to handle those things correctly and appropriately. And in the end, if you think about it, right, these are all orchestration problems. These are not new problems. If you are orchestrating across different services and tasks, these are the same set of concerns that you have to think about in terms of how do you build those systems. And when you think about agents, they exhibit the exact same set of requirements. So if you start to think about it, right, this is what we think about it in terms of what does a production-ready stack for agent look like, right? So if we go from the bottom to top, right, first part, of course, is the tool connectivity. I need to be able to connect to various systems and services that I have so that my agent can use it. Second is, oftentimes, building agentic systems also requires you to build and do a rapid iteration. So how do I kind of build it such that I can iterate quickly, I can visualize those things. Once I have done the first two part where I have an agent working, I need an execution layer that gives me durability, gives me distributed runtime so that I can run my production workload. If I have to roll this out to my 10,000 employees and each one of them are using this heavily, then I should be able to kind of operate this at scale. And finally, we talked about it, right, that I need to be able to get observability. And by that means, what kind of tools it is calling, what are the latencies that I'm observing. I was testing GPT 5.2 last night, and one thing I realized was that it seems to be a little bit slow. You have to tune things before it starts becoming faster. So I need to get all this information so I know what's going on when I change the model. If I move from OpenAI to Claude, is the behavior changing? Is the cost changing? I need that level of observability, right? I also need to know, as I mentioned, the decision-making process as to how agent is operating on it. And finally, I need to be able to kind of govern those things. Just like, we put access control on our services, the same system kind of applies there as well. So if we start thinking about it, right, this is why there is a strong case for having a workflow engine as a runtime for agents. As I mentioned, right, like if you start thinking about it and if you break it down to its basic principles, essentially an agent runtime exhibits the same set of requirements that a workflow engine solves, right? It separates the concerns of development to runtime, right? You can develop things and runtime is kind of taken care by the workflow engine. It provides a centralized governance, and I'm not going to read through all of these things, but essentially some of the things that workflow engine provides are the ideal suit for an agent runtime. And at the core of it, right, what do workflow engines provide you? They provide you task orchestration. Your task could be, in today's world, when you talk about agents, those are MCP tools. It could be also microservices. It could be service workers. Could be anything. You want to be able to run things in parallel, provide decision-making process, be able to handle errors and things like that. But those are the things that you need that the workflow engine provides, and something that agents need as well. And this is why we think that agents and workflow engines are essentially kind of a perfect fit. So how would that look like? Let's say if you are using an agent in a workflow engine. So this is the crux of the whole thing, right? If you think about what does an agent do? So let's take aside the agent for a moment. And let's think about as a humans, how do we accomplish a task? So let's say if you want to onboard a customer for a bank, or if you want to schedule an appointment with your, let's say, a doctor. As a human, you have tools available, and you have a goal, and you have some knowledge. You use that to plan exactly what you're going to do. You're going to plan the steps, and then you will execute those steps. Now, if you replace the human with an agent here, agent kind of is supposed to do the same thing, right? Agent has the context, and this context can come through long-term memory, short-term memory, could be coming through knowledge bases stored in a vector database, or into coming from a regular databases as well, right? But that's the context in terms of what it can do, how it should do. That's your process knowledge. It has access to all the tools. It knows which tools it can call. And when a goal is given, essentially what it does is it plans its execution. This is how I am going to do it step by step. Essentially, it constructs a graph of execution. And then it hands over that. And that's where the job of an LLM kind of ends, if you think about it, right? Language models are very good at doing that. If you give the right context, they can plan things ahead of the time. And then you can give that plan to a workflow engine. And this is where the workflow engine kind of does its job very well, which is that it is responsible for executing that plan. So what it is doing is basically it's looking at the plan and figuring out, hey, I need to call this set of tools. Based on the input and output of a tool, maybe I need to kind of ask a human to approve, reject, or do some actions on it. So it will work with a human, orchestrate the entire tool calling and the human aspect of it, and give back the response. Once the response comes back, the LLM is looking at the original goal. It's looking at the current response and replanning the thing, right? So this loop continues until it achieves the goal and finally responds back to the human. Now, this is more of a conversational bot. It doesn't have to be necessarily conversational also, right? There may not be a user here. The agent can be triggered based on events. It could be running on a periodic basis. For example, if you are monitoring markets for what's happening in the stock market and taking some automated actions, there is no user there, just sending out some notifications and things like that. But essentially, this is the kind of symbiotic relationship between an LLM and agent, which allows you to kind of build agents that can really scale, because you are offloading some of the critical aspect of runtime to the workflow engine here. Yeah, so just to summarize, right? Essentially, you are using an LLM which is responsible for planning and replanning based on the current context. And actually, you are offloading the entire execution part to the workflow engine rather than having LLM do that. And the main advantage of doing that is that when LLM is doing that, right, it's almost like a black box. You don't know what's going on to its decision-making process, versus LLMs are very good at like coming up with a graph of execution and having the workflow engine execute that. And this is where a workflow engine can give you all the reliability aspect of it, right? In terms of it allows you to visualize the graph. It allows you to kind of then look at what's going on and things like that. And here is where I would like to introduce Conductor. So, Conductor essentially is an orchestration engine. It's a workflow engine that we built it at Netflix. And then since then been kind of adopted by a number of companies and industries across the globe. But Conductor essentially brings that set of advantages to that, right? What we have done with Orkes Conductor is, one, of course, at the root of it, it's a centralized and a distributed orchestrator. It gives you durability to your flows as well. So, if things break in between, if there are infrastructure failures and things like that, at 6th hour of your 6-hour-long running agent, it's going to continue and finish in the next 3 hours rather than having to restart all over again. Second, and the most critical piece is, it lets you expose workflows as MCP tools. And this is important because, over the years, everyone has invested significantly into building services and microservices, right, that encodes business logic. Now, for an agent to use that and, rebuilding those things as MCP tools can be a significant expense in terms of both time, cost, and people, right? And this is where, Orkes allows you to kind of essentially take the existing workflows, which can be either synchronous workflows or asynchronous workflows, expose them as MCP tools, and I'll give you a kind of a brief overview and a demo of this as to how that works. And more importantly, it lets you expose your task as skills, which means that all the work, and if you're an existing user of a conductor, you already have invested a lot into building those task workers, and they are all out of the box, readily available as an agent as a tool. And finally, it works nicely with humans in the loop, allowing you to put guardrails. A very good example is, and this is a real example, right? I have been testing my agent, and I integrated via GitHub, and it started sending out and creating issues. So I put in a human in the loop or a guardrail saying that if you are going to do any destructive operation, or first of all, stop it, don't do that. And second was that if you are going to create something in my GitHub repository, please route it to a human. And then somebody can review the issue or a pull request before it starts doing those kind of things. In the end, when you combine all of these things, right, it makes your agent a little bit more deterministic. We know that agents are non-deterministic; they are going to remain that way. But by combining all of those things and snapshotting the workflow it creates, you can get more deterministic output out of all of those things. So yeah, going back to the stack, right? So let's dive a little bit deeper into all of these things. So taking the first one, right, which is how does the tool connectivity with MCP work? So why we built this and why this is important, right, is as I mentioned, right, we have all invested into building APIs, and typically enterprises have a lot of APIs that they have built over the years. Now, if you want to make every API agent compatible, that's a lot of work. And if you have tried using a regular REST API that you have built out, try to make it work with an agent, you would have realized that a lot of these things that were okay to do, things like query parameters, for example, right, or header parameters, those are a bit tricky for an agent to go figure out and use it, right? And one of the reasons why MCP works very well is that it standardizes everything as JSON RPC. Everything is a post request at the end of the day, and in a way it standardizes a lot of these things. Very similar approach to how, for example, gRPC took as compared to REST APIs. But rebuilding all of those things is a significant amount of time. And once you start refactoring, and we all know refactoring also introduces bugs, it's amount of time, you have duplication, and this creates another set of issue is that if I want to go agent first or agentic first, it's not as simple as let's just get OpenAI or Claude or Gemini and start using it. How am I going to retrofit all my services to that is a big issue. And this is where something like an MCP gateway makes a lot more sense, which allows you to take those APIs and services and integrations that you have and exposes them as an MCP compatible endpoint, right? Both stateful as well as recently introduced stateful as well as the stateless MCP tools. And this is what Conductor does as well, right? It lets you take a workflow, and the workflow can basically be a single step. Make an HTTP call to your microservice and return back the response. Or it can be a lot more complex, right? It could have multiple tasks that are getting coordinated and then getting back the results. And those things can easily be exposed as an MCP tool that can be then used by anywhere from your Claude desktop, if you are rolling out Claude desktop to your co-workers in the org, or if you are building applications that are using MCP tools as part of the tool calling and things like that. But it also does one more thing, right? Which is that it decouples your underlying LLM that you are using. Today, this might be Claude, Gemini, OpenAI. Tomorrow, you might fine-tune your own model, some open source model, whatever might be the case, from how you are building services, makes it more usable, plug and play architecture overall. So we talked about this one. And fundamentally how it works is, when you have a workflow, this could be synchronous or an asynchronous workflow, Orkes essentially allows you to expose that workflow as an MCP tool. And then when a request comes through any of the agents, right, either Claude or OpenAI or a Gemini, the gateway understands the request, figures out which workflow needs to be called, calls the workflow. If it has the conversation or the request ID, it continues the session from the previous one. So, if you have stateful MCP tools, that can also be supported there. And all of those things, as MCP adds new kind of specs in terms of authentication and all, we keep updating those things. So you can kind of safely roll those things out as well. So before we dive into this one, right, let me show you how essentially that works. So I have a small or a very simple demo. Hopefully things will work here. So I have my cloud desktop, sorry. So let's start something very simple, right? I'm going to say, let's see if this works or not. As you can see, it's calling a get num service 7322. All right, let's check it out. So what happened here is I have a service here. And it is exposed as an MCP tool. This is the service it called, right? Get num. I have given some description to it. Like if I look at the description here, it says it generates a random number. So, essentially what Cloud does is that at runtime or when it starts, it looks at all the MCP tools, looks at the context and, creates an index. And so when you send a request, it knows which tool to call. What happened here is that underlying implementation here is a workflow. It's a very simple workflow. So if you look at the executions, I should see a random workflow here. Yeah, there you go. And what was the output here? It says 7322. So I have a dummy HTTP endpoint, which basically generates a bunch of random stuff. And there you go, my random number here. This is a very simple hello world equivalent. If I were to change anything on this one, I can essentially change this workflow. It's a very, very simple workflow, but this can get more complex. So let's take a look at a more complex workflow here, right? So let's say I want to onboard a customer for a bank. Let's see if it figures out those things or not. There you go. So I have an onboarding service. It's looking at it. So while it's working on it, let's take a look at it, right? So going back to the same endpoint, I have an onboarding service here. Again, this essentially looks at this customer onboarding workflow, and now this workflow is more complex, right? This is not that straightforward. This is no longer a series of a sequence of HTTP tasks, and there you go. It created account ID and so forth, right? It's a dummy workflow, so really nothing else is happening here. And I'll show you in a bit how I created this workflow as well. But here is the workflow execution. So here is the important thing, right? When this happened, I know the customer was onboarded, but more importantly, I also know exactly what really happened here. So I know for the fact that it does some validation passed. The inputs, I know what inputs were given. I can take a look at it and see, what are the series of steps it took, what kind of checks it did, and so forth, right? Of course, this is a dummy workflow, but if this was a real workflow, then this will allow me to kind of look at everything that is going on there, debug things. So if a customer onboarding didn't happen properly, or if there were issues, I can go back, take a look at it, fix it, or whatever, right? But it gives you full control and visibility into what's going on there. But exposing your existing workflows that you have as agentic MCP tools is as simple as just what I showed you right now. Now, then the next question comes is, as an how do you essentially kind of build the agents, right? So at a very simple things, right? When you think about agents, right, you could have agentic decision making process where you are using an LLM to make decisions, and this could be as simple as, when the user is checking out their cart, maybe you look at the cart and available inventory and give recommendation as to, hey, did you forget something or not? Or it could be as something more complex, like trying to predict a risk score for a user before onboarding to the account. Personally, at Orkes, what we do is we have a workflow that gets triggered every time a customer opens a Zendesk ticket. And we look at the ticket details. We have knowledge base, source code, documentation, everything indexed. We connect to our HubSpot to understand the customer priority and everything. And an LLM decides if this ticket should be prioritized. Let's say a customer sends a request saying, they want to upgrade or they are seeing some issues. And this might be a P2 issue or P3 issue for them. But if the customer is important, the LLM is going to reclassify that ticket as a P1 issue because it's an important customer. Maybe there is a historical reasons behind that and so forth. But now I don't necessarily have to kind of put a human to kind of look at it and say, hey, this should be prioritized. It does it automatically. And then using the workflow, it can trigger PagerDuty alerts. If somebody responds that it's not able to access the system, or it can just send a Slack message or so forth, right? And with humans in the loop, it can automatically respond back to customers saying, hey, we are looking into this. I know this is a P3 issue for you, but we have reclassified as P1 and we are going to respond back to you in a couple of hours. So that's an agentic decision-making process. The other thing could be essentially multi-agent collaboration, right? And this is where workflow engines really becomes important because if you think about it, right, if you have multiple agents talking to each other, you are either using a very simple kind of auction-based approach, right? Sending requests to all the agents in parallel, getting the results, using an LLM to summarize the result, or choosing the best result, whatever might be the case. Or you have agents which contains other agents, so you have very deep nested hierarchical agents. Those things are a breeze to build with Conductor because essentially agent is a task. You can nest the tasks and so forth, right? And more importantly, you can get visibility into it. Every task can be long running. It can run for minutes, hours, days, months. It doesn't really matter. The system will persist its state. It keeps it durable, survives the failures. And then comes how do I actually go around building these workflows, right? And this is where, a lot of feedback that we got was, workflows are very powerful, but figuring out how do you actually take an existing process that you have and construct a workflow can be time consuming, right? And by time, I mean, it could be hours to do that. And the question is how kind of easy it is to do that and how can we simplify those things? And the whole idea is that, if you give the right context and your process documents, system should be able to build workflows for you, right? So we are talking about now agents to build the workflows. The other advantage there is that, a lot of times the processes themselves are deterministic. A customer onboarding doesn't necessarily change between two customers, right? The process can be well defined, but an agent can build that process a lot more efficient, much quicker. And if you want to adapt to new requirements, you can use an agent to build those things. So that if you think about that as it's an agent to build workflows, and then, the workflows can be executed. And workflows can contain agentic task itself. So, it can be non-deterministic workflow or it can be a deterministic workflow, depending upon what is it that you are trying to solve here. The another advantage that you have with something like this is it's easy to explain things. We have all been through that cases where somebody from the business side comes in and asks this question about just explain to me what you have done here, right? And you start writing the Confluence docs and Word or Google Docs and explain to them. And oftentimes it's a boring work, but it's required, and oftentimes it's required for collaboration and things like that. And this is where agents do a very good job, especially LLMs. When you give them the plan, it can describe very clearly exactly what it is, and then you can dial up or down the complexity of what it is explaining depending upon the user. It can be as simple as very businessy, or it can be more technical also, right? So that's another advantage of having something like this, where explainability of the system becomes much easier to do. Documentation becomes a trivial task at that point in time. And more importantly, the documentation is living and breathing because you are not necessarily writing it once, because we all know the documentation is outdated the moment you write it, because somebody else is already changing it by documenting it. And of course, you can use the prompts to kind of, get operational insights also, right? The other advantage of having a workflow engine now is that you have a lot of insight. We just saw, right? Like when I ran a query, I can go back to the UI, I can query those things and find out exactly what happened. And that's a very powerful thing, because when things are completely fine, nobody looks at the UI, nobody looks at the search queries and APIs to do that. You need that when things don't work. So it's an insurance in the end. So let me show you how that works. So the workflow that we just did for the customer onboarding was actually created through an agentic system. So, okay. Essentially, one of the advantage of Conductor is that Conductor essentially acts as a repository of all of your services and tasks and integrations, which allows the agents to understand exactly how to accomplish a particular task and what are the constraints, what are the tools available to it. So we'll try it here. This was the previous prompt here. This is what I used, but let's do this, right? Let's try something different now. If you are curious, we are using Claude 4.5 Sonnet behind the scenes here. So there are a few things it is doing, right? Like one is it is trying to kind of reuse what is out there. And so first thing it does is, it checks if you already have existing components available. And the whole idea is not to reinvent stuff all the time. Rather than that, reuse whatever is available, kind of promoting the reusability across the board. And it also kind of gives you the thinking process in terms of what it is trying to do. And that's important because, you want to know what's going on there. And there you go. Of course, these are all dummy APIs here, example.com. But if you create the tasks inside the system, it will kind of go and reuse those things, which means the workflow becomes runnable from the get-go. But there you go. Still going on. But I think you got the idea. It's going to go on and complete the work here. But building complex systems becomes much easier here now. Yeah, it's done. And you can test it from here. You can start using it through APIs and so forth, right? So that's the other aspect of it, right? Like, how do you improve the kind of overall developer productivity to go from 0 to kind of 1 when it comes to building new agentic systems? This is where one of the areas where we have been kind of spending time, because it's easy to, like, we have seen a lot of tooling around building front ends. Where you need to spend a lot of time is kind of building the backends, right? And backends are a lot more complex oftentimes. And the moment you put state there, it becomes even more complex. And of course, you can use humans in the loop and so forth. And of course, underneath all of those things, what's driving all of these things is the orchestrator, right? The conductor is the one that is doing all of the work. And it offers you kind of that durability, fault tolerance, allows you to kind of have long-running workflows. It can stream the state to an event pipeline. So, if you are using Kafka, RabbitMQ, NATS, it can publish those states as things are happening. And then you can collect those states, put it into some other database, use it for analytics and so forth eventually. Just a brief history of Conductor before we break for kind of the Q&A. But we started Conductor at Netflix. It was open sourced. We built Orkes to kind of bring Conductor as an enterprise about 4 years ago. And so far, so good. I'll stop here and happy to take any questions.
Is there one biggest concern for production applications are the concern of adding new features or changing existing features without breaking the others? Is there also, on that note, is there a way to write like end-to-end tests for an existing workflow?
Yeah, so yes. Short answer is yes. Slightly longer answer is there are two solutions to it, right? So one is, of course, you can write end-to-end test, you can write unit test, you can write what I call it regression test. So you can have a set of golden inputs and then use that to verify that they produce the right output and things like that. Other part is that versioning workflows can be versioned. So before you create a new, before you modify things, you try to you create a new version of it, maybe run an A/B on the two versions before you roll out the new version to all the users. Yeah. And this also applies to kind of agentic systems, like what I have seen with some customers as they are kind of moving things to more agentic systems. They have a deterministic workflow. They created a new version that uses agents and they are doing A/B testing before rolling out. And that applies to both going from deterministic workflows to agentic. And then later on, even when you are changing things, right? Like if I am moving away from OpenAI to Anthropic or just changing the model itself, things will break, almost guaranteed. So, you want to test it out, you want to run it in a production environment before you feel confident that, this is good to go. Yeah. Yeah. Yeah, we do. We don't publish it because it's, there are a lot of nuances to it. But in the end, the Conductor was built at Netflix. So, there were two important things, right? One, we designed it for failure, not for availability. So things can go down, system continues to operate. That's the fundamental, because the moment you start running things at scale, things are going to go down. If you design for availability, you are always on call. You design for failures, you're going to sleep peacefully. Second part is the scale. So, you can, and scale goes, in my opinion, two ways, right? So one, of course, is the complexity. You can have really complex workflows with, large amount of fork joins. Like, you can fork out thousands of tasks in parallel and run them. Second part is in terms of the volume. So, Conductor can handle literally, tens of thousands of QPS in terms of the request. Of course, eventually you are going to get bottlenecked by network and you might have to add over more cluster. Other part is that for synchronous workflows, it can go as low as single or 2-digit millisecond latencies, the entire workflow. Of course, it depends how many tasks you are orchestrating and things like that. But in both ways, it performs much better. Yeah.
Can you repeat the latency that you were just talking about and how you achieve the latency?
So there are two modes to running the work, right? If you're running asynchronous workflows, of course, they will be running for a longer period of time. It could be as low as few hundred millisecond or few tens of milliseconds. When you are running synchronous workflows, where you have a bunch of microservices being called either sequentially or in parallel, that latency can be a single-digit millisecond latency. Of course, assuming that, so essentially the idea is that the latency that we try to measure is how much overhead do you put as an orchestrator to bring the durability. Of course, nothing comes for free, right? So the moment you add durability, it introduces few millisecond latency between the tasks. But we have ability to kind of relax that requirement, saying that I can have the durability at the task level, saying every task must be durable. That's important if I am doing payment processing or onboarding a customer. The other aspect is that I want durability at the workflow level, whereby I have a bunch of synchronous tasks. So let's say if I'm doing credit card authorization and then checking for the inventory, that can run synchronously and it's idempotent. If something fails, I can restart from the previous step and continue forward. So that can be asynchronous, and there the the latency introduced is probably 1 millisecond or less than that. So, it can go really as fast as your microservices can go. And then workflows can essentially get persisted and become durable the moment it hits an asynchronous task. So, you could have a set of synchronous tasks, and that's useful for things like retail use cases where as a user, like the moment you hit checkout, you want to do a bunch of things sequentially as fast as you can. And then there comes the fulfillment and order processing that can happen asynchronously, can take days, but there you want durability. So, one single workflow can achieve both of those things. Yeah.
You handle voice with your workflows?
Not yet, but in theory you can. But inherently, system APIs, we don't really have a real-time API right now, which I think for voice you would need. Something that we will consider if there is enough demand for that. But yeah.
Do we need to use an external database for storing the workflows state?
So open source conductor supports multitude of databases ranging from Redis, Postgres, MySQL, Cassandra, Orkes. We use combination of Redis and Postgres. We found that to be a best combination. They are both open source and it scales very well. But that's the stack that we use. Yeah. Sorry, you had a question.
Can you utilize this in a private network on-premises data center?
Yeah. So, of course, the conductor is open source, so you can run however. As Orkes, we have multiple deployment models. So we have fully hosted, we manage entire infra. You can bring your own cloud, which means that we can manage inside your cloud account. So you own the data, you have private keys and everything. And it can also run on-prem. And on-prem, today, people define it two ways. Either you are running your own cloud your own way, that's on-prem. But on-prem could also be data center on-prem, where like you really have a data center somewhere in Heightstown, and then it's running there. Yeah.
What would the contribution model be? Like some big company like Booking.com said wants to adopt this, and then we actually figured out there are some parts of the pieces that is not necessary and we want it a certain way.
Yeah. So there are two things, right? Like one is that, of course, the tasks are worker model, you will write your own. And so that's one part of it. But the conductor itself, the core itself is open source, right? Which means, a lot of these things that we use also have come as contributions from the community. So, yeah.
So there's not much of a difference between the open source conductor and Orkes. Like that's what I'm trying to.
Yeah. So the different, so if you think about so the core is open source, which means that the whole workflow execution piece is coming from open source. Our typical release model is that we build stuff in open source, we bring it inside Orkes, we keep it a version or two behind because our customers care a lot more about reliability than latest and greatest stuff. And what we do is that we add the other aspects of it, right? The security part, governance, role-based access control. So we focus on those things. Open source also, if you notice, it's a very plug and play. You can pick whichever components you want to use for database and everything. So as I said, we use combination of Redis and Postgres. So that's our own kind of internal stack that we use. But apart from that, everything else is open source. Yeah. Thank you. Thank you all.